So this is the second part of 4.1. We're going to investigate a little bit further. If you missed the end of the first video, we just explained why a 45-45-90 triangle has these rules. Otherwise, you just might need to memorize this. So a 30-60-90 right triangle has these rules, where the short leg is across from the 30-degree angle, the long leg is across from the 60, the hypotenuse is always the hypotenuse across from the right angle, and we have this relationship. Now, I didn't get a chance to say it in the first video. I ran out of time, because sometimes you're given the hypotenuse, and you'd have to divide by 2 to get the short leg, and then multiply that answer by √3 to get the long leg. And sometimes you're given the long leg, where you have to divide by √3 to get the short leg. You might need to rationalize the denominator, not a big deal, and then double that answer to get the hypotenuse. Okay. So these rules are already written for you, or you can write them down right now. You might need to go back to your geometry and think about how you got those answers then. Our next example, we're going to, if we're given this information, where we know AC is 11, CB is 16, we have enough information to figure out everything else. Most people, or my encouragement to you will be to never use a rounded answer. And the other thing I need to mention, because some people are still doing this wrong, is we round to 3 decimals. So the first thing I would do, if you are rounding, you round to 3 decimals. First thing I would do is a Pythagorean theorem to figure out AB. This is my opinion. That would be 11 squared plus 16 squared is equal to the hypotenuse squared. Use C squared. And then from here, I would just use a calculator. Didn't mean to have that still in there. And you can leave your answer as, by the way, that's side length AB is equal to the square root of 377, because remember that number I gave you is C squared, so you have to square root it. Now, if you can simplify that, then by all means, go ahead, try to find factor pairs. Otherwise, if there's no simplest radical form, go ahead and just square root it, and again, 3 decimals, so 19.416. Please let me know if you are not good at rounding. By the way, some students want to round twice. We never round twice in math. I don't know who thinks that, but you only look at the next number. Do not ignore that 8. Ignore that 8. Do not look at that 8. So that 4 is smaller than 5, so that 6 stays the same, 19.416. All right. And by the way, if I go back to the answer key, you can even see he leaves it as that. So earlier I mentioned only use perfect answers. So knowing that the hypotenuse is that 19.416, but finding angle A, only use the 11 and 16, the perfect answer. So if you look at angle A, that is opposite over adjacent, and that's tangent in SOHCAHTOA. So tangent of A is equal to opposite is 16, adjacent's 11. So go to your calculator. You don't have to use my calculator. Just make sure that you are in the correct mode, which I already changed in the first video, to degree. Let me know if you're struggling with that. And you hit second, tangent. To find the angle, you do the inverse tangent. I already forgot what the number was, 16 over 11. And because we're in the right mode, it'll give us the correct answer of 55.491. Again, do not round twice. It just so happened that happened to us. 55.491. And then the same thing would go for angle B, except opposite of B is 11 and adjacent is 16. So angle B is going to be inverse tangent of 11. 11/16. I'm going to use the answer key. 34.509. I don't mind if you remember from geometry, your teacher probably put measure of angle. Measure of angle. I put squigglies anytime we round. I don't know if you've noticed that. That means approximately. And yeah. Okay, let's move on to the next one. So they give you, on the next one, CB is 12.5. They give you angle A, measure of angle A. I just wrote that. Look at that. It's 43 degrees. Well, the first thing I would do is figure out angle B, because we have 2. We need the third. Well, the 3 angles have to add up to be 180. So 180 minus 90 minus 43 tells me that measure of angle B should be about, exactly 47 degrees. It's equal to measure of angle B. Okay, so then from here, I actually don't mind any of these angles because these are all exact. I didn't approximate anything. So maybe what you would do is just start with sine. I'm going to do sine of 43 degrees. Remember, it's always sine of the angle. I guess I should be a better teacher. You should be putting the degree symbol every single time. I haven't been doing that yet. And there's a reason for that, but right now, just trust me. And what we have is the opposite of 43 is a 12.5, and the hypotenuse is side length AB. But we don't know that, so we'll just put C there. And so what we can do, and how I typically teach it, and it seems to work, is I think students are really good at cross multiplying and dividing. So sine of 43 you can put over 1. So I've had a lot of success teaching this where students understand that it's C times sine of 43 degrees is equal to, 12.5 times 1 is just 12.5. So now to solve for C, it's going to be 12.5 divided by sine of 43 degrees. And I'm just going to type that into my calculator. 12.5 divided by sine of 43. And you get an answer of about 18.328. And by the way, now would be a good time for you to mention that is side length AB. I just don't want to write AB, AB, AB several times, so I wait till the end. And this answer makes sense, okay? If you think about a right triangle and the angles, well, the largest angle needs to be across from the largest side. So far, that is the largest side. I really want you to be a good critical thinker, a good problem solver, and make sure your answer makes sense. So the next thing I would do is I would use tangent of 43 degrees because of opposite is 12.5. And adjacent would be that side length AC, which I'm going to use side length B, lowercase b. We usually use the lowercase letters for side lengths, by the way. I don't know if you've seen that before. So if you do the same work, the calculator will look almost the same, but I'm just going to go to the answer key. I don't even like his answer because he rounds. He used a rounded answer. I would deduct a point on the answer keys. I don't like his work. And what's he thinking? Rounding and don't trust these two answers. But his answer to AC is good. 13.405. Because he used exact answers, exact numbers, and then round at the end. So 13.405. So be careful with these answer keys. So AC is about 13.405. All right. By the way, feel free to make notes and come ask me questions in class, whether that's in Google Classroom or if you set up a one-on-one meet, whatever you need to do to be successful, just let me know. Most students are pretty familiar with finding area of a triangle. So the area of a triangle, let me write this up, is 1/2 the base times the height, which is awesome if it's a right triangle. The problem is we'll be looking at oblique triangles. So in this problem, so this is an oblique triangle. I'm looking at triangle ABC, by the way. Definitely an obtuse triangle. Well, I shouldn't say it's definitely, but it looks like it's obtuse. And as you look at this height, we don't know. I know the formula looks like we know it, but we don't. So what we'll be examining is what if we know, let's say, two side lengths. Let's say we know side length A, we know side length B, and we know for some reason angle C. So what the whole premise of this is that we can figure out the height. Because it's a right triangle, we want to find the opposite in that right triangle, and we have the hypotenuse. Well, in SOHCAHTOA, and maybe I should clarify, sometimes I take your prior knowledge for granted. I'm talking about this right triangle. That's why I'm saying we have SOHCAHTOA, and so, S-O-H, opposite and hypotenuse. This is the hypotenuse in that right triangle. So what I'm saying is that sine of that angle C in degrees is equal to H over B. So the whole premise then is we can solve for H, the height, by multiplying this B over, because it's a division problem. So B times sine of C. Now this is going to be confusing because I use B up here as well. I probably shouldn't have done that. 1/2 base times height. And in my work right here, the base is not letter B. The base in the problem is made with a right angle. So that's side length A. So what I'm trying to get at is the area is 1/2 times side length A, and the height in the problem we just figured out is equal to B times sine of C. And instead of working through the notes this way, through the example, this is the area formula that we will be using. So let me go to the answer key. And this is really the intention of the problem. In geometry, you probably remember 1/2 base times height. Well, look at this triangle. The base is side length A. The height is H in this problem. So the person making this answer key went ahead and said, oh, okay, well, what if we know side length A, and we know side length B, and we know angle C? Okay, well, we can find H by setting up a trig formula like this. So 9 times sine of 67 will equal the height. So he went in and did that. And then he found the area by doing 1/2 times A times the height, which is right here. And because I'm running low on time, this is going to be a 3 or 4 video lesson. There's 3 different ways that we can write this formula to find the area of an oblique triangle, a non-right triangle. So go ahead and pause the video and go ahead and write one of these. And they're all the same, by the way. Notice that the angle needs to be included between the two sides. So 1/2 AC sine of B, that's the same thing as 1/2 AB sine of C. The angle must be between the two sides. 1/2 BC sine of A. And I'll see you in the next video.